Why is pressure sensor accuracy so critical? Imagine trying to balance a glass of water on a thin wire. Even the slightest shift can cause a spill. That's how important accuracy is when it comes to pressure sensors. These tiny devices are everywhere, from medical machines to industrial plants. They turn physical pressure into electrical signals that control systems relying on. If these signals are off, the whole system can react wrongly. For example, in a chemical plant, a pressure sensor monitors the pressure inside a reactor. If it reads too high because of inaccuracy, it might shut down the process unnecessarily or worse, cause an unsafe overpressurization. In medical devices like blood pressure monitors or ventilators, precise readings are vital. An incorrect pressure reading could mean the difference between safe treatment and potential harm. Accuracy depends on several factors. Non-linearity is how much the sensor's response deviates from a straight line. Hysteresis is the difference in readings when pressure is increasing versus decreasing. Repeatability measures how consistent the sensor is under the same conditions. Temperature effects can also influence readings, especially if the sensor isn't temperature compensated. These factors are combined mathematically to give an overall accuracy figure, often expressed as a percentage of the sensor's full-scale range. For example, a sensor with a 100 psi range and a 0.5% full-scale accuracy could have an error of up to half a psi at any pressure point. High-end sensors can achieve accuracy levels of plus or minus 0.05% of full scale. More common industrial sensors might have errors of plus or minus 0.25% of full scale. The choice depends on what the system needs. Precision manufacturing, aerospace, and medical systems demand the highest accuracy. Some industrial processes can tolerate a bit more error, which helps keep costs lower. Temperature plays a role too. Most accuracy specs are given at a standard temperature, often 25 degrees Celsius. In real-world conditions, temperature changes can introduce errors, so sensors with good temperature compensation are essential for consistent results. Long-term stability is another key factor. Over months or years, sensors can drift, losing some accuracy. For systems that need to run reliably over long periods, selecting sensors with proven stability is important. When engineers choose a pressure sensor, they balance accuracy with cost and environmental conditions. They carefully read datasheets to understand how accuracy is defined and tested. They also consider the signal conditioning circuitry, which can influence the overall system accuracy. In embedded systems, this might involve filtering signals, calibrating software routines, or converting analog signals to digital. In many applications, pressure sensor accuracy is the backbone of safe and efficient operation. Whether managing a complex industrial process, monitoring environmental conditions, or controlling a medical device, precise pressure readings are essential. Inaccurate sensors can cause process inefficiencies, damage equipment, or even create safety risks. That's why understanding and specifying the right accuracy level is a fundamental part of designing reliable electrical systems that use pressure sensors.